Also one come.
Now see here.
You
Once again. Einstein's photo. See, two more topics are planned after left after this. Small topics, not big one. So Einstein's photoelectric equation or energy quantum of radiation. So this is the surface, metallic surface or photosensitive surface. So when light incidents on this one, electrons are ejected out, and this is a work function. H nu is the frequency energy of the incident radiation. Energy. H is Planck's constant. Nu is the frequency of incident radiation. H nu energy of incident radiation. Nu is the frequency of incident radiation. Phi is work function. Work function means this is the minimum energy for which the electron come to the surface of the metal, and the remaining energy will go, and it will have kinetic energy. So K, that is K is kinetic energy of electron. Phi 0 is work function. So we get value H nu is equal to 5 plus R maximum kinetic energy. Then bring this on the other end, we get phi 0. H is Planck's constant. What is Planck's constant? 6.624 into 10 to the power minus 32 joule second. Now, if H nu is greater than, means this energy is greater than this one, what will happen? The remaining energy will go in this one. So, what is phi 0? Phi 0 we have H into nu 0. Phi 0 means H into nu 0, where nu 0 is threshold frequency. Threshold frequency means the minimum frequency of incident radiation for which photoelectric emission takes place. And V0 is the stopping potential, means the minimum potential of anode for which the photoelectrons are stopped, means rejected by the anode. And nu 0 is equal to what? Cross multiply this, we'll get this. And kinetic energy maximum is equal to EV0. From where we got? From here. V is equal to W by Q, W is equal to VQ. V, W, and work done and kinetic energy are having the same dimensions, that is joules. Both are measured in joules. And here, instead of Q, I wrote E, electron. Instead of V, I wrote V0. And here we have H nu is equal to phi 0 plus EV0. Bring it on the other end. Then where nu is greater than nu 0. So what will happen now? Cross multiply this, you'll get this. Then V0 is equal to H pi into nu minus phi 0 by E. And it is in the form of Y is equal to mx plus Y. C is the intercept, pi intercept, M is the slope. So from here we were able to find out the Planck's constant. See how we did. See, this was the fourth graph, right? So what he did, he just took it here like this. This what is Y intercept? This one is the Y intercept here. What is that? C is the Y intercept. That is minus because this is negative because it is down below the origin. Below the origin, that is the reason it is minus. Got it now? And this value is how much? Phi 0 by E. This is very, very important. Even for the numericals, as well as it can come for question also. And what is the slope? His slope is how much? The slope is H by. So from this graph, they found out the Planck's constant. Is that clear? Okay, copy this one fast. Then we can go to the next topic. Is it clear? No. Of electron, the photon. He gave the concept. This photon, see, photoelectric effect is the evidence that light is particle in nature. Okay, interaction with matter. That it was made of quanta or packets. Okay, so he says that light travels in the form of photons. In the form of quanta. Light travels in the form of quanta or energy packets. Light travels in the form of quanta or energy packets. Okay, so that is equal to H nu. Where is your phone? Just one second. Okay, now. See, there are 5 points to be discussed. In interaction of radiation with matter, recording, please.
Yes,
So now, in interaction of radiation with matter, radiation behaves as if it is made up of particles called photons. So the first point is details about particles. Light travels in the form of particles, that is photons. It's the first point. Okay, interaction of radiation with matter.
Sir, who told this?
This is Einstein. Okay, Albert Einstein. The second one is each photon has energy. Second one, here I'll write here. Interaction of matter with radiation. Interaction of matter with radiation. Interaction of matter with radiation. This is the first one. The second one photons have energy E is equal to h nu. Photons have energy. What is that? The E is equal to h nu, or it is also written as P, or momentum. Momentum P is equal to mv. Momentum P is equal to h nu by c or h by lambda. H nu by c or h by lambda. These are the two formulas he has there. Third one. Okay, the third one. All
Sir,
photons of light.
what is lambda?
The nu is the frequency, lambda is the wavelength, c is the speed of light. Okay.
It is not that.
So third one.
This should.
Third one. All photons of light of a particular frequency and wavelength have same energy. Okay. Same frequency. Like if you are same frequency particles have same energy. Particles have same energy. Same energy. Same particles have same energy.
Hello.
So what is the formula here? E
What
is
is the
equal to
precision
h nu, or the same formula. By increasing the intensity of light of given wavelength, there is only an increase in the number of photons. Increasing the number of intensity. Increasing the intensity of light. Increasing the intensity of light increases the number of photons per second. Number of photons crossing. Number of photons per second crossing. Crossing a given area. Okay, so same frequency particles have same energy. It's like yellow color particle. If you have yellow color, like we have light, in that there are thousands of particles. Every photon, particles means here photons. Okay, keep that in mind. When I say particles here, I'm mentioning photons have same energy. So it as increasing the intensity of light. Increasing the intensity of light. So increasing the intensity of light increases the number of photons per second crossing per unit area. Photons are electrically neutral. Fourth point. Photons are electrically neutral. Photons. He speaks about photons. Okay. Photons are electrically neutral and not deflected by electric or magnetic field. Electric and magnetic field.
Okay.
Not deflected by electric or magnetic field. Clear? The last point, fifth one of this one. He says that photon particle collision, the total energy and momentum is conserved. Whenever there is in photon electron collision or photon particle collision. I'll try point. In photon particle. Photon matter है ना, matter के साथ interact हो रहा ना. Means this is the photon. Okay. ये आ रहा है, ये hit कर रहा है ना यहाँ पे surface पे. That is a particle. Understood? So in photon particle collision, both momentum and energy are conserved. Both momentum and energy are conserved. Momentum and energy are conserved. Is that clear? In photon particle collision, both momentum and energy are conserved. Okay, so this is what happens. These are the five nature. Once quickly see here, light travels in the form of quanta or energy packets. He told to Albert Einstein. So particles before Albert Einstein was Max Planck's constant. Max Planck. He gave that concept of particle nature. Particle are nothing but photons here. That is interaction of matter with radiation. Second is photons have energy E is equal to h nu and momentum P is equal to h nu by c or h by lambda. Same frequency particles or photons have same energy. Like yellow color, all the yellow color particles have same energy. All blue color have same energy. Increasing the number of intensity of light increases the number of photons per second crossing a given area. Photons are electrically neutral, not deflected by electric or magnetic field. Next, in photon particle collision or a photon collision, momentum and energy are conserved. Last thing we have, that is about we are going to discuss about the wave nature of matter. It doesn't take only, it take hardly 2 or 3 minutes. I can finish up. Please copy this quickly. Is it clear, Ismail and Arham? Any doubt in this one?
Yeah. Yes, it's clear.
Yes.
It's clear.
No, I know some vibration in the front. What is it?
Now,
I thought
so can I erase this now? Can I erase this?
Yes.
Yeah. Okay.
So 2 seconds
Okay.
on the last part.
So wave nature of light. Wave nature of light. So wave nature of light, de Broglie wave. Okay, wave nature of light, de Broglie wave. So according to de Broglie, see, de Broglie, his research was under on dual nature of matter and radiation. The topic actually, his thesis or his research purpose on dual nature of matter and radiation. He said, like as I told you in the beginning, there are some scientists who proved particle nature of light, like Newton supported particle nature, and then Max Planck. Then after Max Planck, who was that? Albert Einstein. Okay, Einstein, he supported the particle nature. Okay, then after that, wave nature was supported by whom? By Huygens and who is that? Young's. Okay, Young. He supported the wave nature of light. Clear, but the problem was he wanted to work on both. That means he wanted to prove that light has dual nature. So he wrote the thesis and he submitted to the university. I think he belongs to France. Okay, so when he wrote the thesis, then all the scientists, they want to reject his thesis first of all. Professor decided to, because it's very difficult, right? How can it be dual nature? At that time, somehow proved it practically. He did not prove it practically. He gave theoretical concept, because there are 2 types of research. One is theoretical research, one is practical research. Theoretical research is very difficult, actually. Mine is theoretical research, very difficult. And after that, I put it in programming. So you have to do a lot of research. You have to go from 100 years back, like 200 years back, like that. I started from 1850. Theoretical, you have to find out all the research papers, what they have done from the beginning. So we have to do, first of all, what is a literature gathering? The literature we study, literature, we gather the literature we study. So that's the way we do it. So he did on theoretical research and he wanted to prove it, but the professors wanted to reject it. But in research, it's not like that. You cannot just accept it like that, or we cannot reject it. It's not like grade 12 or something like that. You have to give proper evidence why it was rejected or why it was accepted. Both the things you have to give. So they want to reject it, but they don't have any evidence to say that it is rejected, just like that. So they wrote a letter to Albert Einstein, who was in London at that time. I told you, he was born in Germany, then he went to London, from there he went to US. He got the nationality of US when the Second World War was going on. So they wrote a letter, then he replied, Albert Einstein replied to the professor that send me the thesis. They sent the thesis. Then the thesis means the book, what we compiled. So after reading the thesis, Albert Einstein replied to the professors, if de Broglie proves what he said is correct, then we all will become fooled. Then he told, award him the PhD. So in 1927, I think, in 1924, he was awarded Nobel Prize, PhD for the same topic. He was awarded the Nobel Prize also. He was awarded for the same one. He got the Nobel Prize, same concept. You know what he proved actually? He said that particle has dual nature, and every particle is associated with a wave. Means every person is having a character, right? Good character or bad character, whatever it is. Okay, yeah. So that is also still a character. Yeah, is it not? Every person is associated with a character. So every particle is associated with a wave. So that wave is how much? Wavelength is that wave has a wavelength. Means when a particle is, suppose a particle is moving like this, it is releasing some wave, having it associated with a wave. So that what is the wavelength? Lambda is equal to h by p, which is equal to h by mv, which is equal to h by under root 2 me. There are 5 formulas here. I'm writing in one equation, under root of 2 mev, which is equal to h by under root of 2m capital E, which is equal to h by under root of that is h by or 1.22 by root v Armstrongs.
One formula they can't do.
Like all formulas in one
Five
go.
formulas they-
Out of this, definitely one question will come in examination. One marker. No, many 5 formulas instead of writing separately, I wrote in one go. See, H by it is in terms of
So the
wavelength.
P is equal to mv, P is equal
Yeah.
to 2 root of.
H by is momentum, mass and velocity in terms of voltage, in terms of energy, in terms of this is for only electron. This is for electron. Okay, just keep this in mind. This is the electron. If for proton means it will be different.
H by नहीं उसके बाद
What is momentum? mv, right?
हाँ
What is the relation between momentum energy? P is equal to under root of 2 me, right? So that I wrote here.
so this is for voltage
This is for momentum. This is for velocity, mass and velocity. This is for
Vol-
voltage. This is for energy. This is for electron. Means they compiled it already. 1 nanometer means how much? 1 nanometer means how
10
much?
raised to 6
Nanometer means 10 to the power of God bless you.
minus
That's fine.
सर आसपास ही था minus
Micrometer means how much? 10 to the power of minus. Micrometer means how much?
God, this is for board exam. It will be.
Yeah, minus 6 meters.
oh yeah
This is the value. Okay, so this completes your topic.
oh yeah
So tomorrow I'll be starting atomic physics. Is it clear? Learn this one. I'm just erasing this part. Learn this. Are you clear with this, Ismail and Arham?
Yes, sir.
Okay.
Look at the confidence.
So that is a tragedy of de Broglie wavelength. And how did he prove actually experimentally?
Not all
After
needs
this,
have
after this, how,
needs-
listen.
people think-
How did he actually prove this one? After this, division in Germany, 2 scientists, they were doing research. And then they also published the papers on the same concept. And this de Broglie met those guys. And then how did they prove? Suppose, example, listen, this is interesting. If it is only particle nature, how it will be on the screen? We'll get only particles, right? If it is, this is particle nature of light. If you are doing some experiment, on the screen you will get particles. If it is wave nature, on the screen should get only lines like interference pattern. Have you seen? Diffraction pattern, red dark fringes. That one, that will happen. But this is wave nature. But how did he prove that it was dual nature? What happened? He took the film like this on the screen. Like there are some like patterns like this. Okay, like wave nature pattern. Okay, like this. Thick bands are there. With the microscope, he magnified this thing. When he magnified this thing like this, he saw so many particles very close to each other. That is how he proved that this is not there in our book. This is actual thing which is missing from the book. So this is how he proved that it has dual nature. Yes, one band is formed due to the particles. They are very close to each other. When he magnified that one, when he magnified this line, one line like this, he got so many particles in it. Means it proved, this proves that wave nature, this proves particle nature. Means dual nature. Got it now? So that is how de Broglie and German, they proved it experimentally, dual nature of matter and radiation. Because of this, today we have powerful microscopes, SEM and TEM. We can magnify the image from like up to 1 lakh times. Means this much particle you can magnify that much because we are using electron microscopes. We are not using light microscopes. Electron microscopes, SEM and TEM.
one in our biolab is
That is
light.
normal light. That is based on light. SEM and TEM. That is this
Sir,
cost of this is
Expectations.
cost of this is 2 crore Indian rupees. It is in
Yes.
IIT Madras and IIC Bangalore. I saw this one. So scanning electron microscope, transmission electron microscope.
He's expecting that to be in LPS.
No, this is not very. I don't think so. It is in India, big lab, Bristol lab.
Sir,
Even we are not supposed to operate also. There will be technicians will be there. You give the sample, they will give the output. They won't give us to touch. What is completely vacuum, like completely. You are not supposed to enter that. Completely prohibited because alignment. It is very fine alignment. That's a problem. Okay. Then thank you so much.